Hello Internet, welcome back. Today we're going to be working on some more fractals. I have a terrible idea and it's going to be awesome. So just to catch you guys back up, this is what we have so far. Well, I've changed it slightly. I haven't actually changed any code. The only change I did was I changed this guy, this rotation, to be at 90 degrees so everything just kind of splits and you get this cool rectangle. I thought it was cool. I don't know. Anyway, what we're going to be doing is we are going to be adding hinges onto every single one of these that we create, and then it's going to kind of bend, which sounds like a terrible idea. And I think it is a terrible idea, but I think it's going to look sweet. So we're going to see where this goes and also explore a little bit more with this whole messaging thing. So first off, just so I don't break anything too soon, I'm going to reduce the recursion down to a manageable number. So simulating physics on hundreds of intersecting bodies would be, I don't want to deal with that if it's wrong. So anyway, I'm going to change it back to what it was. So that it should look like our standard tree. Next, we just have this. I'm going to add a pivot and move that to the top. And so each component is going to attach to the pivot of its parent, if that makes any sense. So this pivot is what the new branches that this one spawns, their rigid bodies are going to attach to that, and that's going to be their anchor. So we're going to call this our pivot. Simple enough. And I'm going to save my prefab because that's what I do. And then I'm going to make this a rigid body. And it's going to not use gravity and, well, we'll have it use gravity and be kinematic. And the reason we're doing this is so that when I take this next guy, where am I going? Scripts. We want to create a new script. This new script is going to detach and hinge. Yeah, so what this is going to do is it's going to, how do I want to do this? It's going to detach the object from its parent, and then it's going to take that parent and attach it as the hinge. And so how this is going to work is, I'm going to copy from here. Just take this, plug it in there. Well, we don't need to require a component, but we do need a reference to a hinge. Public hinge joint. Hinge, and we're going to set this hinge dot connected body equal to this transforms parent, and we're going to get the rigid body off that. Get component rigid body. Okay, so none of this is going to work yet, and it's not detaching either. I'm going to save this into a variable quick. Their parent body. There we go. So none of this is going to actually do anything. It's not going to work at all. This will exist, but there is no parent. The parent isn't being set. And there is no hinge. The hinge doesn't exist either. So what I'm going to do is in this instantiator, I'm going to add a transform. And this is going to be root node. And so what this is going to do is it's going to take each of these recursive components that we created, and it's going to parent them to it. Serve.transform.parent equals the root node dot transform No, we don't need the transform. We already have the transform. There we go. So all this is going to do is take the parent and set its root node. Well, other way. It's going to take the root node from the current node we're on and set that equal to the parent, the ones it's generating. So if I do this now, it should still break. Nothing's going to happen. So what happened there is it set the transform to the parent to null, and that just means it's parented to the world. So nothing actually changed there. But we can change it by taking this and attaching our pivot to it. And while we're at that, we're also going to attach a rigid body, and that can be kinematic without gravity. And so now we have a rigid body at the top. This guy is also a rigid body. There's no hinge yet, but I just want to run this and make sure everything's parenting correctly. So every generated node should be a parent of, or should be a child of its parent, of these pivots. And I may have broken things. Transform.parent. Huh. I do not know what happened, but I clearly broke it, so that didn't work. Let's kill that quick. Quicker than that, preferably. Great, 1 sec, I'll be right back. Alright, welcome back. So Unity was taking up 8 gigs of my RAM, and that was just going up. I'm pretty sure I created an infinite loop. So this is probably bad. Not fully sure about that, but pretty sure. So this is still not going to work. We're going to take the copies, transform parent, set it to the root node. Actually, I'm going to make this a string. And the reason I'm going to make this a string is that it will fix this problem. I believe what's happening is that this pivot is staying as a reference to that previous component, the previous pivot, and so it's doing some bad stuff. Not necessarily sure that's what's going on, but I don't really want to dig into that right now. So what we're going to do is we're just going to make this do that, and then we're going to take this .find .get children, find, okay, I was thinking there's a way to find children. Okay, component in children. Game object. Find game object. Well, actually, we can do some link here. So I know the child is going to be there. So I can do this dot. Well, part of the components is, so the children are all tied to the transform. So I don't think there's a way to actually get the children, just the parent. So it's just a one-way tree. And doing this would be slow, so I don't think we want to do this actually. So we're going to use the game object as the root node instead. I don't think that'll fix it, but I'm going to check quick. I've got control panel open so we can kill it really quickly when I fail again. And okay. There's that type mismatch. You meant to be not you. You meant to be you. We'll apply that, save, and break Unity. Okay. And it crashed again. Kill it. and restart. I guess this happens sometimes. I should have probably tested this out first, but that's kind of the point of these, right? We both get to learn at the same time, so hopefully you're learning something. Specifically, don't do this. So the issue seems to be this. I'm going to actually step through this and make sure what I think is happening is actually happening. So we're going to attach to Unity and go through this. This is weird. Oh, okay, it did hit it. Okay. So there's that. We've got our forward vector. We've got our Euler angles. I think this is good. Position -3, 2.3, 0.5. I continue. Should get a different one now. I get 2.03. Yeah, those are different. This one, that's not any different. That's the same one. But that one's different. So they are changing. They appear to be changing. So I'm going to remove this and stop Unity. Shit, I didn't mean to do that. That just broke it. Oops, my bad. One sec. We'll get this eventually, or not. Maybe this video will just be a whole bunch of fail. Alright, now we're back. We've got this. Actually, we can do this the easy way. Vector 3 pivot position. And what we want to do is we want this to be at transform.position. Oops. We want our pivot equal to game object dot instantiate. Well, we can just do a new game object actually. This will do the same thing. So if you don't know that, creating a new game object does the same thing as calling instantiate on a game object. And if you do new game object and instantiate, it will create two of them. Create the first one and then it will copy it. So we don't want that. I'm going to just call this the pivot dot, and I'm going to parent it immediately to this one. Then I'm going to move it and set the local position equal to the transform scale times the pivot position. And I'm going to multiply by y because that, yeah. So this is going to take the y vector of our scale, which we're shrinking by, and it's going to multiply by this. You can't multiply vectors by vectors. We covered that in the last video. It doesn't line up. It doesn't make sense. And if you learn linear algebra, it doesn't really make any sense to multiply a vector by a vector. But you can do this. So that's what we're going to do. And so now we have the pivot. So I'm just going to replace this with our pivot. And now it should work. Come on. Don't do this to me. Come on. We can be friends. No? You're no fun. I'm starting to think it may not appreciate all this parenting. Well then, kill that. We'll start it one last time. And now, we're not going to do that anymore. I believe we can send additional arguments here. I hope we can. No. Okay, so what we're going to do is we're going to create a arguments list. This isn't exactly what I wanted to do. I was thinking it would be easy, but it isn't. So we have to work around that. So we're not going to parent everything because apparently that doesn't work. What we are going to do is we are going to create a package and we're going to pass in the pivot and we're going to pass in that index. So instead of getting one argument, we're going to get two. So this is going to be our recursive bundle. Not particularly happy with that name, but it works. And it just needs an integer, which is going to be the index. And it needs a game object, which is going to be the pivot. So now we're going to pass this guy. So this is going to generate a new one of these. Whoa. Recursive bundle. We're going to pass in the index, which is just I, and the pivot. There we go. And it doesn't like this, so we're not going to do it that way. We're going to do it this way. So this is just another way of instantiating an object in C#. We can take all of its member variables and we can actually just pass them in at like this. So I'm creating a new one and that's going to have an index and a pivot equal to those values. So that should work. Now we just need to change all of these to accept this bundle instead. So just going to copy this and pass all of these in like so. And just for sanity's sake, I'm going to cut this down to 2 and kick it off. Okay, so it's mostly working. It's shrinking, but it's not rotating. We can fix that. And that's because of these two exceptions, which are coming from here. Bundle.index. There we go. So now it should look exactly like it did originally. And I may have even left the parenting in, so that still exists. Kind of confused why it's only doing part of the tree there, but we're gonna move along anyway because I don't think that's a problem with that. I think it's a problem with something else. So the transform was still working. That's interesting, but I'm not going to do that there. Mostly just because I don't want to. And because it was crashing things, and I don't appreciate things that crash my things. Okay, so that works. There we go. So we've got our branches. They are being generated. They have a lot of pivots. And that is because they are being generated with a lot of pivots. It probably didn't think that through very well. Yeah, we're gonna leave that. Don't you worry about that. We'll deal with that later. I say as I'll never deal with it later. Right. So we actually have the pivot. We're actually getting that now. And this thing should be connected. So the next thing we want to do is make sure our hinge is actually connecting to the pivot. And the way we're going to do that is we're going to take... What is it doing? Hinge.connectedBody is equal to this. No. So that's not happening anymore. We're going to use the bundle pivot. And we're going to get that as our parent body. And so bundle.pivot. There. So this will get our rigid body off of that. One thing there isn't is a rigid body on this. So we're actually going to just add one, which is also a terrible idea because we're copying this each time. So there's going to need to be some cleanup that happens here. But we're going to get this working and then we're going to do the cleanup stuff. Don't give me those eyes. See them through this camera. You'll see. I see that. Okay. Moving on. We're going to do this. And these guys don't have a hinge. And they don't have the hinge connector. So that obviously doesn't work. So here's this. Detach and hinge. Doesn't exist. Cool. Move him up. Break our component. I don't know why adding one doesn't, but apparently moving it does. Whatever. We've got our hinge, so we're going to add that. Hinge joint. Cool. Connected body. That's going to be set by our script. Spring. This is what's going to actually give it our movement. I'm going to use 10. Why 10? Ooh, whoa, hello. Why 10? That's a good question. I like 10, okay? And we want to use the spring. All right, cool. This should work. The only thing we're not doing is I'm gonna ask for a copy of this rigid body too. And the reason I need this is because it's currently kinematic, which means that it's only going to move when a script says move this much. But we want it to kind of move on its own. So I'm going to make it not kinematic when this gets called. And so ideally what this will do is it means the root node is still going to be kinematic, but everything else is not going to be. So if this works, it should kind of wilt because everything's affected by gravity. So it should kind of bend. Yeah, it should just bend. That we'll see if that actually happens. So here we go. No. The answer is no. And the reason is these aren't set. Okay. So now that those are good, let's try this again. Well, that was interesting. But it wasn't really what I was looking for. It wasn't really at all what I was looking for. So that guy's there, and that guy's falling. Why is he not attached? This is a good question. Don't have the answer to that. This one doesn't even have a rigid body attached to it anymore. That's interesting. Can't add component rigid body because it's already added. Pivots, holy geez, pivots. I can fix this. Okay. How do we fix this? First, before we create a new pivot, this is a dumb idea, but I'm going to get all the components in the children that are of rigid body. And for each. No, that doesn't exist yet. Dang it. Okay. So for each body in our children that is a rigid body, we want to destroy it. So this should destroy all of the old pivots. I think. I'm gonna test that quick, actually. That's probably the intelligent thing to do here. Oh no, that is not the right. That is wrong. So he's wobbling, but he's wobbling wrong. And the other one just blew himself up. If name is equal to pivot. Yeah, this is a good idea. We're gonna get all kinds of bad code in this video. Okay, didn't blow up our pivot, that's good. Created a ton more, that's bad. It's already added. Pivot equals that. Pivot.transform. I don't know what's going on here. Something is very broken. I was thinking this was going to be easy and I could just set the transform and it would all work. I was wrong. Guess that's kind of a good thing, but it's also really annoying. What if I just pass a reference to its parent, the recursive instantiator that created it? Because if I do this, if I do parent equals this, then I'll have access to that pivot position. And I can attach it to this one's rigid body. Yeah, we're going to do that. We're going to get rid of this because that's bad. And we're going to do this instead. So go over here, change this to be the parent, and it's going to be a recursive instantiator now. So now the only one that's using that is here, if I remember correctly. That appears to be correct. So how we want to do this is get the parent's component, and now they ought to have a rigid body on them, like that. Set this one's rigid body to not be kinematic, parent that to that, and set the there is a point where we can set our connected point. Where is it? Connected body, that's wrong. But there is connected anchor. And we want to set that equal to the bundle's parent's pivot position. Now I think this is in local. I think that's in local position, so they're local coordinates. So this should work. If it's in world coordinates, this when the parent starts tilting, the other one's just going to stay put, and that's wrong. But if it's in local coordinates, and it should be, then we're good. Then we're fine. This should work. I say as I'm scared that it's just about to blow up in my face. Oh well. We're learning things. That's promising. It doesn't look promising, but it's promising. That's very promising. I'm liking this. Cool. So it's working. So now, let's up the recursion to 6. Scared to do this. Last time we did 6, it broke. Well, that didn't work at all, but that's awesome. Okay, cool. So we have this, whatever this is, we have this. I'm gonna set some limits here. I don't actually know how these work. So does it go negative? 0 to infinity? No. Minimum that works 40, 30? Sure, we'll do 10. 10 sounds like a good limit. Yeah, it did. That didn't work at all. Okay, well, I need to use them, that's why. Okay, let's see if this works. There we go. Now we have a tree that does things. I'm gonna up that a little bit to 30. That looks like a sad tree, but it looks like a tree. Cool. All right. So that was horrible, and we screwed up all over the place. But we got this. A sad, dead tree. Yay, I guess. I don't know, I think it's cool. We can do this to a tree and it just kind of falls over. Yeah. Whatever those hand gestures were, think of it, it's this. Yeah, I'm bad at hand gestures. So I think that's it. I think that's all we need to do here. Obviously there's way more we can do. But this kind of gets the ground started. And frankly, a lot of it is just parameter tweaking. A lot of it, since it's all just all this stuff passed in, we can just change how all of that works. Like we can change where this pivot position is. Am I even using this anymore? I don't know if I am. Oh, yeah, that's why. Okay. So yeah, we can change that and do all of this stuff. Actually, now that I think about it, kind of confused why this pivot position being at 0 works. I don't know. I'll have to look into that on my own time. But that's all for this video. So thanks for watching, and make sure to check out the project out on GitHub. There's a link down in the description. So check that out and do something cool. So until next time, see you, Internet.